What's up, geometry students? This video is about points, lines, planes, and their intersections. Open your notebook to a fresh page and go ahead and set up a table like this. So you want to make sure that you put your title, points, lines, planes, and their intersections, and then set up a chart so that we can organize all of the vocab words we're about to go over. The first vocab word is point, which you've heard of before. You graphed points last year in algebra. So we already know what a point looks like. It just looks like a little dot. So I'm going to go ahead and add that into our picture column. And you may already remember that when you name a point, so first of all, this word notation is another way to explain how you're going to write something using a symbol or naming it. So when you name it, you simply would just say point A, okay? But what's the definition of a point? What is a point? A point is known as a small dot with no dimension. Our second word is line, which you've also graphed last year in algebra. So a line connects any 2 points together. So I'm going to draw a line here by labeling 2 points A and B. You can really select any letters that you would like. And if I connect those points and extend in both directions, indicating that with 2 arrows, that is how we would draw a picture of a line. The way that we would notate a line or name a line is by choosing any 2 points that lie within that line. So points A and B, always using capital letters. And above those 2 points, drawing a symbol that would represent this as a line. Here's our definition for a line. It contains at least 2 points, but keep in mind that it is possible to have more than 2 points on a line. And a line extends in 1 dimension. Our third vocabulary word is plane. Okay? A plane, as you may notice a pattern, a point has no dimension, a line has 1 dimension, a plane extends in 2 dimensions. Okay, also looking at another pattern, we have 1 point, then we have a line which contains at least 2 points. A plane contains at least 3 points. When you look in your textbook or on a worksheet, or if you attempt to draw a picture of a plane, we typically draw it something like this. It looks like some type of quadrilateral, but really this is a way of representing a plane on a flat surface. We have to remember that a plane continues on forever. So a few examples of planes: your desk, the wall, any flat surface. Since a plane contains at least 3 points, go ahead and plot 3 points within your plane and give them a name. Make sure you label with a capital letter. I'm going to use ABC. If we wanted to name this plane, we would simply write the word plane and then any 3 points that are on that plane. So plane ABC, plane BAC. The order doesn't matter because all 3 of those points are on that plane. Let's say there was a 4th point. There's no need to use all 4 points to name the plane. You only need 3. Sometimes a plane in a diagram will have another type of special letter up in a corner, and there will be no point with that capital letter. Typically it will be cursive, but sometimes not. That also represents the name of this plane. Because it is not associated with a point, you can just say plane M. It would not be acceptable to name this plane A because A does not represent the plane. The capital letter A just represents this one point. Our fourth vocabulary word is line segment. Really similar to the word line, but whereas a line extends in both directions forever, it never stops, a line segment has two endpoints. So it's going to look very similar to this diagram, but it will not have arrows extending beyond those points. It will simply just look like this with endpoints, and it stops. It's very easy to confuse the notation for a line versus a line segment because they are so similar. Since I chose the same exact letters for this line and this line segment, I'm going to use the same two capital letters that are my endpoints. But instead of putting the notation for a line like we did on word number 2, I'm just going to put a line segment above those two capital letters. Another interesting thing about a line segment is because there's two endpoints, it's not really specified where does this line segment begin and where does it end. Is it A to B or is it B to A? So you actually could name this segment BA as well. And that would be acceptable. You could also do the same thing for a line. Our fifth word is ray. A ray also looks similar to a line or a line segment, but it continues in one direction. So a ray has something special called an initial point. And that is like where the ray starts. And then it continues on one side of that initial point. So it continues in one direction. And that's going to be the side that has the arrow. Go ahead and draw 2 points, A and B. I am going to make point A our initial point for this first ray I'm going to draw. So that means that this ray is going to continue in the direction of point B. So if I were to name that ray, it's very important that you always start with the initial point, which would be A, and the ray extends towards point B. Okay, so the symbol above those two capital letters is like a little miniature ray, and the arrow is always pointing to the right, even if your ray is not going to the right. So again, I'm going to use points A and B, but this time I'm going to make my ray start at point B and go forever in the direction of point A. So your ray can face any way. It could go left, right, up, down, diagonal, it doesn't matter. But when you write the notation, you always start with the initial point and then another point that the ray is moving towards, and your symbol always goes to the right. So you may want to add a few notes in this column. That first point is always the initial point. Okay, so naming with the order of letters does matter on a ray, whereas the line segment and the line, it doesn't matter which letter you put first, it does for a ray. And then your notation is always going to go to the right. Even if your ray is going to the left, you still draw the symbol to the right. Our last vocabulary word is opposite rays. And that one sounds kind of self-explanatory. You could probably take a guess that this is going to be two rays going in opposite directions. Okay? The thing that makes opposite rays special is that they have the same initial point. So they are connected essentially. They are going to look like a line. So I'm going to draw a ray with the initial point C going to the left. I'm going to put another point here. I'm going to call it A. So this is ray CA. If I were to draw another ray that would be considered an opposite ray to ray CA, I would need to have the same initial point, right? Initial point C. But instead of going to the left, it's going to go in the opposite direction. So I'm going to draw another ray going to the right. And I'll name that CB. So ray CA and ray CB are opposite rays. Okay, so one last time to recap, the main difference between the ray versus a segment and a line is, well, first of all, it extends in one direction, whereas a line segment stops on two endpoints and a line continues forever. But you really have to understand the naming for a ray. It's very different because you always need to begin with the initial point. There's a few more vocab words actually that I wanted to go over: collinear points and coplanar points. So both of these vocab words have the root co, which kind of means like with or on. So collinear means points that are on the same line. So points that lie on the same line. A picture of this, kind of self-explanatory. You can draw a line and a series of points that are on that line would be collinear. So go ahead and plot 4 points. And I'm going to name them points M, A, T, H. Let's say I wanted to refer to all of those points. So points M, A, T, and H are all collinear. I would simply write the word points M, comma, A, comma, T, comma, H are collinear. Coplanar points are points that lie on the same plane. So we're going to do something interesting here after we get this definition. Points that lie on the same plane. Go ahead and draw a little plane. And we are going to draw a line going through that plane. So imagine for a second that you are going to put your pencil right through this piece of paper. So there were some points above the paper, and then there would be some points below the paper, and maybe a point on the paper. So I'm going to draw it like this. And this is a little dotted line, in case you can't tell, indicating that it's behind there. So go ahead and draw 4 points anywhere on this plane. Draw a point at the place where that line is going through the plane. So I'm going to do A, B, C, D, E. Then we'll draw a point way down here on the line, F. So you can start to see that some of the points are on the same plane, A, B, C, D. E is on the line, but since that line is touching the plane, it's also on the plane. Point F is on the line, but it is clearly off of the plane, so it would not be considered coplanar with the other points. So our notation is just going to say points A, B, C, D, and E are coplanar, and F is not. So what we're going to do now is a little index card activity that is going to help you discover how we would represent the intersections of these basic geometric figures. So we've got the point in a line, two lines, a line in a plane, and then lastly the intersection of two planes.